Can you hear me? Awesome. Well, folks, thank you for having me. I'm super excited to be here. I think when I first met the Akash team, it was love at first sight because the core value proposition of decentralized AI, and by the way, I'll talk not just about healthcare, but I'll also talk about 6G, just because I think both are an awesome opportunity to do decentralized AI. So decentralized AI, privacy preserving learning with applications to healthcare. I'm a professor at UT, but before I get started, I have to thank the people that have helped me be here today, right? And they're students, collaborators, and partners, right? These are people who are responsible for a lot of what I'll talk about today. It's great to be a professor. It's great to take credit, but it's actually the students who deserve the credit. Now, why am I so excited about decentralized AI? Why have I been so excited to work with Akash? It's because decentralized AI makes a lot of sense for certain applications. It makes a lot of sense. And I'm going to try to make the case today in the 20 minutes I have that it's not just certain small apps, it's not just niche cases, it actually makes global sense. And I'll talk about why it makes so much sense, hopefully, and convince you. You're already convinced, but hopefully convince you further in the next 15 minutes. Okay, so for a while I taught all the tech crypto classes at UT Austin, which is not Texas A&M, just to make sure, is just up the road. We're about 10 minutes away from UT Austin. UT Austin is the flagship school in Texas. And part of a big Texas UT ecosystem. We have 14 campuses, a bunch of medical campuses, and a bunch of 200,000 students or something like that. So I used to do a lot of what's called information coding theory. Currently, I do a lot of AI and distributed systems. That intersection is fascinating. I have about 12 PhD students, exactly 12 PhD students, and then that's the division. So I have students who do AI, I have students who do crypto, but you won't believe this, there's very few who do both. And I see a genuine opportunity in doing both. So if you're interested, you're at the right space, in the right place, the right group, Akash, please come talk to me because I'm looking for more people who think decentralized but also think AI. All right, oops. Let's see, did I overshoot? Okay, so what's the problem? The problem is data is generated on the edge, right? It could be health systems. It could be IoT. It could be cellular. It could be sensors. Data is also consumed on the edge. In fact, models are used on the edge. Most inference systems try to be as distributed as possible. So why is modeling done in this centralized manner? If you think about it, most of AI ML, you'll see 99% is modeled in a centralized way. That means, typically, the mindset is pool the data, build, pre-train, fine-tune, and particularly pre-train, right? Centralized, and then finally distribute the inference. And the reason is because these systems are not co-architected. The data collection, the data orchestration, the data modeling, and ultimately consumption and inference, if they were co-architected, can be done in a much more decentralized way. And there's strong benefits in doing so. But the cons are very few. Okay. So why is decentralized ML an opportunity? It's an opportunity because the value in terms of the model itself, in terms of model parameters, in terms of what can be done in terms of sparsifying the model, improving the model, fine-tuning the model, can all be done in a decentralized way while offering a lot of the benefits of edge computing together with the benefits of cloud computing. And I'm going to go into different architectures that do that. I'm likely preaching the choir here. I know I'm in a mixed audience. Some people will go, oh, this is obvious. Some others might go, are you sure you can do everything centralized AI can in a decentralized way? And I'm going to tell you pretty much I can. In fact, in some applications, it's impossible to be centralized. It doesn't make sense. Okay. All right. So decentralized AI, again, comes in two flavors. There's a fully distributed AI. Message passing algorithms, belief propagation models, etc. A bunch of methods in distributed statistics means distributed machine learning. And there's what's called federated learning. I'll spend more time on federated learning. I think some of you are already very familiar with that concept, but I'm going to talk about it. If you're interested in fully distributed learning, that's one of my areas of interest. I'm very happy to talk to you about it. But in a fully distributed learning model, there is no master-slave. There is no central versus edge. It's peer-to-peer completely. In a federated learning model, it is structured to be partly central and partly distributed, okay? In that it's decentralized, but there's a distributed component and there's a central component. Now, I know most of you know what I'm talking about, but I'm just for emphasis going to go into this. There's data, and that data goes into what I'll call local edge models that then get pooled. The models get pooled, not the data. That then gets pooled into a central model, where the central model updates the local models as the updates come along. So the parameters here, and I'm going to try to use my pointer without looking away. Let's see. No, okay. All right. The parameters here are that the aggregation process is done in a privacy-preserving way, perhaps in a much more efficient way than a centralized framework, while the training and a lot of the heavy lift on the data side is done locally on the edge, right? And this doesn't have to be what's called the far edge. It doesn't have to be a phone. This can be done on what's called the near edge, which is different colos, different remote computing environments. And there is a significant benefit in doing so. All right. Okay. This slide is a big eye chart. There's a formal definition of federated learning, which essentially says I mix a centralized mechanism of building a model with the distributed way of capturing all the data in such a way that both worlds benefit. So why does this make sense? Okay, and we've known that this makes sense actually for a while. It makes sense for at least 4 reasons. It may make sense for more than 4 reasons, but at least 4 reasons. The biggest driver whenever people you hear about talking about distributed AI or federated AI is privacy. But honestly, privacy is not the only reason. Okay, privacy because the data never leaves the local environment. Okay, and the local environment doesn't have to be actually co-located. It can be a virtual local environment, right? So it could be data that is actually in Akash's network, but doesn't leave that network to go to the centralized server, right? So there is a way to structure this where the decentralized system manages the data and has all the right permissions just for that, while the model is still enhanced by everybody. One of the biggest factors you'll see is bandwidth conservation. Data in many applications, especially real-time data, just cannot be uploaded. It doesn't make any sense. The locality of it. Now, locality is a big deal. You look at the applications I'll talk about, the locality will matter a lot. And finally, latency. I actually want to start doing real-time AI updates. In that case, if I'm doing real-time AI, I just cannot afford to be able to pulling the data. Okay, so these are 4 major factors why decentralized AI is not just essential, it is critical, right? In fact, the 2 problems I'll talk about, healthcare and 6G, I don't know how to solve them without decentralized AI. It's that big a deal, right? Because if I insisted I had a centralized model, I don't know what to do. I get totally hamstrung, right? Okay. Now, here are two examples of systems that you might have heard of that use federated learning or decentralized learning in general. You can do your traditional LLMs in a decentralized way. So anybody who told you that to build an LLM model, I need to have all the data pooled, no, you don't. Right? You can actually build traditional CNNs, RNNs, and then LLMs and general transformer models, multimodal transformer models in a federated way. That's number one. Number two, you can do applications such as Siri, and Siri actually does it in a federated way, right? Per the press release. And I believe the press release, so yes, per this press release, it does it in a federated way. Okay, so for those, see, Apple is not constrained, but per this press release has chosen to do this in a federated way. So why do it in a federated way, right? Privacy is a big concern. But there's an even bigger reason, okay? Let me take healthcare, and I have 9 minutes. So I'm going to take healthcare and then 6G and give you why decentralized AI is the only way to do them. Not the right way, the only way. Okay. What is the problem with healthcare, right? Let me go back. Privacy. Oh my God, privacy, right? The healthcare folks live and die by privacy. Privacy is a big deal. You might say bandwidth conservation is not a big issue in healthcare, and you're right. But even in healthcare, when you want to be able to do fMRIs and a whole bunch of data, centrally pooling it really doesn't make too much sense. Yes, if you're just dealing with regular records, maybe. But when you're dealing with much of the massive data sets that are often created, especially in an inpatient situation, pooling it doesn't make too much sense. The locality of it. Healthcare is hyper-local. If you have a patient data in Northern California, you have patient data in Northern California. It does not correspond to the patients in Ohio and doesn't correspond to patients in Texas. Any claim that because you've seen a lot of patients in Northern California, that you know your patients in Texas, is not correct. So it's hyper-local. And if you ever want to do real-time inference, which we'll hopefully get to someday in healthcare, you do want to make sure that you can do real-time updates. But privacy is the biggest reason why in healthcare, federated learning is the only thing that makes sense. So whether it be local hospitals, whether it be payers, the Aetnas and Optums and the CMS in the US, or it be international ultimately, or it be ordinary users that may have their own devices they want to use to be able to do healthcare AI. This data collection is most effectively done and effectively pooled in terms of creating the model in a federated way. I cannot go into certain details of this, but there's a good reason a good healthcare foundation model doesn't exist today, okay? And the good reason for that is that even with anonymized data, healthcare data has to satisfy certain regulatory constraints. As you must have heard of Mayo and Google teaming together, you must have seen those press releases if you've not. But the Mayo and Google teaming together is going to only model Mayo's patients using Google resources. It doesn't scale. With decentralized data collection and modeling, we have perhaps not just the most promising solution, we have the only solution to be able to build a global model. Otherwise, it's the regulatory environment plus constraints, plus the fact that it's hyperlocal is going to drive, this makes it unscalable. All right. Now, in 6 minutes, I'm going to make the case for 6G next. So most of you have heard of 5G. Most of you are going, I've heard of 5G, what the hell is 6G, right? Or no? 6G is coming, and the work for 6G is happening now, right? So it's the next big thing in telecom. Tens of billions are going to be spent by every government each year on 6G, tens of billions, okay? And 6G, again, will have AI and metaverse natively integrated. That's part of the design. It'll do 10 gigabit per second with 1 millisecond latency, all right? So it'll be equivalent to your 10G base T copper connect or fiber connect. There's a huge opportunity here for everything edge AI. And there's an opportunity to really shape 6G right now, right, over the next year. Now, why 6G plus decentralized AI? In 6G, the problems, you remember the 4 problems? Privacy, bandwidth, latency, and what was the last one? Let's go back. Locality. 6G is a very interesting characteristic. It has all 4 problems, okay? If I try to do 6G AI in a centralized way, I'm going to drown. I can't be sending every user data or even network data up a pipe. I'll be sending petabytes every day. How do I manage actioning actual data if I'm also trying to send network data at the same time? I'm just going to throttle my pipe. Locality. What happens in Austin, Texas is very different from what happens in Fargo, North Dakota. It's very different from what happens in LA. The wireless environment is completely different. Latency. 6G is all about latency. If you don't get that file, a user perceives latency more than they perceive anything else. So, the right way to do 6G is decentralized AI. And the beauty is everybody is coming to that conclusion. So edge AI, or fully distributed AI plus federated AI, are the most promising architectures for 6G. The model effectively can predict everything from where the congestion points is to which applications need to be served, what's called provisioning, network provisioning and tracking, to network security. That should say all down to network security. And I'm helping design this right now for 6G architectures. All right, so what's the summary here? Decentralized AI algorithms are the future of many applications, whether they be healthcare, 6G. I just gave you 2 applications. I've already promised Cheng and Greg that I'm going to give you many more in the future. And the reason is that the more I see the need for AI to be truly decentralized. There's an important point I want to make. This is not that decentralized AI is a cheaper, more scalable competition to centralized AI. It's that decentralized AI is the only solution. That centralized AI just cannot do this. I hope that makes sense. And that's a huge deal. I don't see centralized AI ever building a scalable foundation model for healthcare. I don't see centralized AI ever doing 6G. And so there's a big opportunity here. All right. Now, let me speak about teaming with Akash. So Akash is poised to be, I think, the solution for the world. And I'm looking to team with Akash to build the world's best decentralized AI solutions together. In fact, my hope is to bring some of these, not just use cases, but these transformative solutions in AI, not just healthcare. I think healthcare is great. Not just multimedia and metaverse, not just 6G, but beyond, to the Akash ecosystem. The goal is to target, hopefully, 24 startups in the space. And then hopefully in the very near future, we'll be communicating a shared space, a way to make this happen, and we'll be sharing more details with you soon. So I appreciate your time. I have a minute left, and I'm really excited about decentralized AI. In fact, I could not, if this is the right place and time to change the way we think about AI, all the way from data collection, modeling to inference. Thank you very much.
there anyone that had a question? Sure.
Quick question, which is, how do you explain something this complex and heavy as a professor when you're obviously teaching your students, PhDs, other profs? It's a bit easier. How do you explain that to someone who's just interested in what you're doing? Let's say, your aunt.
For sure. Can I get philosophical for a minute? Because hopefully that philosophy will help inform why I think the way I do. I believe there are at least 3, maybe 4 factors that make something work massively. Permissionlessness, composability, recursion, and ultimately atomicity at some level. Now, if a field has 4 characteristics, 3 of them being critical, it takes off like wildfire. AI and crypto have that in common. Permissionlessness until a point, composability, and the ability to recurse. Right? Now, the reason I'm making a big deal about this is that AI and crypto have architecturally a lot in common, much more than you think they do. If you were to use these 3 properties very effectively, the 2 are a positive cycle. They help each other and can be wildfire. So another way of thinking about it is AI doesn't have to be centralized, never had to be. We just did it that way because that's how we knew. If you think in the mindset of decentralization from the start, permissionlessness from the start, composability from the start, you can architect things that are naturally hand in glove and are much more powerful together than separate. It's 1 + 1 makes, by the way, I did my PhD in applied math, so I should never say this, but it's 1 + 1 makes much more than 2. There's a genuine opportunity to do that. All right, I'm over time. Well, thank you.